Okay, hello CISC 4906ers. Welcome to tutorial 2. Today we're going to be going over a quick 10-minute approximately tutorial on the introduction to data science. You should be seeing this tutorial roughly around the same time that we're going to have our first project meeting. So very much in theme with the projects for your course-long projects this semester. This tutorial is basically going to cover the types of scraping material that you should be somewhat familiar with, or that you'll hopefully become familiar with if part of your student group project contains a scraping component. So really, this is going to be a very introductory, like live demonstration of how one would put together a scraper for accessing data online that may be updated regularly, or not easily downloadable, say through like an export to CSV button or some kind of JSON file download. This is trying to basically parse through either static HTML or JavaScript rendered files or documentation online that we wouldn't necessarily be able to access easily without some kind of automated method to do so. So this is basically just the intro slide. I'm going to kind of jump right in and close this down. I'll introduce some of the initial project materials. This is the type of stuff that if you've attended the introductory tutorial or meeting on the projects throughout the course, this GitHub should hopefully be familiar to you. It's been put together by myself and Dr. Khalil. And it'll contain and be regularly updated with material on the course. So this is obviously the winter 22 offering. And if you go into this project ideas subfolder, you'll get a sense for all the different project ideas that we've proposed that you might pick up as student groups to pursue for this course, or from which you can inspire your own ideas. There's recently been added this other tutorials folder. I'll jump into that quite soon, but just jumping into these project ideas. So during the first project meeting, in part of a synchronous way, I will already have gone over some of these ideas with you. So please reference back to this location throughout the semester just for various ideas. The projects that are listed here are under two different formats, whether they're structured ideas. So basically, either they have pre-existing data sets or they're already ideas that might have a scraping component to them, but much of the work has kind of already been thought out to give a general starting direction. So there's about, I think, 4 or 5 projects in that vein. And then near the end, there's the undefined project ideas. These are less well structured because maybe not all the data sources have been perfectly identified, or it's uncertain if those data sets exist. So that's more on perhaps each student group, if you're interested in one of those, to do a bit more research to figuring some of that out. A recent one that I've added here near the end might actually be turned into a structured project, but it's basically going to be the basis for the scraping tutorial today. So it's on scraping GoFundMe, and I'll get a bit into that in a little bit. But before doing that, I'll just give you guys a bit more information on just scraping in general. I've had the pleasure of already doing a bit of work on using data scraping in general with a few collaborators at the University of Toronto and University of Winnipeg. We basically wrote a piece on how we could apply data scraping like en masse for applications within social sciences. And if your project has a data scraping component to it, I'd recommend going through this paper. It gives a general overview on some of the different kinds of hurdles, the legal implementations, ethical concerns. Some of it has no real bearing on how you're going to put together the actual technical scraper itself. There's a lot of tutorials out there on that, but this gives a good overview as to kind of how scraping in general could and should be used in different domains. And at least this one's specific to the social sciences, but you might get a sense that a lot of the different ideas that we're throwing around in this data science course could have a very clear tie to certain things like social sciences. It's relatively high level, but does touch on certain things like the legality and ethical implications of scraping. And if at any point during the semester, or if you're starting to put together these scrapers yourselves, you have questions about that, feel free to reach me by email, and I'm happy to delve into this. But this is one such resource. The other thing is, part of this work, we had within its supplementary material. So there's links to the GitHub here within some of the READMEs on the page. We do kind of a breakdown on how you can basically build out a scraper for increasingly complex tasks. So I mean, in this first example, we just start with a simple Python-based request to get the HTML or to acquire a certain file online that we can print out. Then we get into a bit more complicated things. So depending on how difficult the task is, the complexity of your scraper is going to vary, and it's not all websites are made equally easy to access information. So hopefully the tutorial today will give you a bit of insight into that. So we talk a bit, or here we introduce Beautiful Soup, at least version 4, which is something that we would want to use if we want to render in an automated way a web page, and it differs from some other libraries. So today we're going to use Beautiful Soup, so BS4, as well as Selenium, and so on and so forth. And anyways, this gives you a few example scripts that you can basically implement to access data in different ways, but it will really depend on what your original source is, and how much you dig into things to really get a sense for how difficult of a task it would be to scrape that. So jumping into, I'll go back to the idea for today's scraping example. So the idea here is, and it is a particularly timely one if you're watching this during end of January 2022 in and around Ottawa, Canada. So the idea is, can we scrape GoFundMe active fundraisers to ask a number of questions about the types of fundraisers that are ongoing during a pandemic is just one idea, or one question we could ask. Can we scrape the history of donations for a given fundraiser to query where those donations are coming from? So the names, at least, of those who are providing donations and how much they're providing. For large scale fundraisers, so say things on the order of greater than $1 million, does the history of donations for certain fundraisers contain a significantly larger proportion of quote unquote anonymous donations? And these could perhaps, so this is just a hypothesis, could these perhaps be indicative of significant influence from foreign actors? And for individual GoFundMe pages, there already exists a GitHub scraper that you can access here. There's a link to that. And another exciting thing is the GoFundMe wiki page actually lists a number of the biggest fundraiser projects with an active status. So actually, to give you a sense for what that is, if you go to GoFundMe's wiki page, you can see that there's a number of different projects going on. Some of these might be more interesting to us than others, being Canadians in and around Ottawa. Some of them are active, and so on and so forth. And these are all relatively large, so we can get a good sense for a number of active fundraisers at a time. So the idea here is, if we could scrape those history, is it that some of these have a significantly larger proportion of anonymous donors than others, and if they do, what might we extrapolate from that as a data science question? Sorry, so going back to here, so there's a very interesting article that was recently put out, a CBC News article with some preliminary findings that, so the fundraiser of interest that we'll use for this tutorial is the Freedom Convoy 2022 fundraiser. CBC News has been scraping the publicly shared donations for about a week up until today, and they've amassed about 35,000 listed donations. And the reason why a scraper is so useful in this use case is that the public records are only available up until a certain amount of time, and they get kind of renewed with every new donation that comes in. So this is a very active donation right now. So I'm just going to close out the developer tools here just to give you a sense for what this looks like. But this is basically the link to GoFundMe.com, Taking Back Our Freedom Convoy, under the subdomain donations. If we don't have the subdomain donations, we come to this main landing page, and if we click this see all, we see that the URL pulls up this donations bit. And so even a minute ago, we've had a number of different donations come in. And if we were to scroll through this all the way down, we can see we can actually load up the latest donations for the last however long, up until 40 minutes ago to an hour. And so our interest here would be, because this is being updated regularly, the only way we can access the history of this donation or fundraising campaign would be to grab this at regular intervals. So say every half hour, you run a script that would go in and just pull all the donations through here. And what we would want are basically this first name, the dollar amount, and perhaps the timestamp, or at least the timestamp since the current time. And that would be able to give us a reasonable measure as to when these donations are coming through. So when building out the scraper, what I'll do is go to the tutorials subfolder. So in this tutorial subfolder, I started putting together basically some of those materials. So a link to those scraping examples. I'll be growing out this link to, or these links to, other scraping resources to getting started. But the main one for our purposes here is this scrape GoFundMe donations history.py. So basically, this is a script I put together for this very task. And the general breakdown of a scraper has just a few components to it. Near the top, you'll want to import a number of different things. So again, we're using Beautiful Soup, Selenium. We're using a sleep timer. So we don't want to, the purpose of using a kind of sleep delay is to not overbear the servers on a website. Like, one thing that, if you read some of the documentation or that article that we had written about, one way that websites will prevent scraping is they'll block any IP requests that have been hitting their website at very quick intervals. If you're making requests on a website for like hundreds or thousands of times within a couple seconds, you could easily get your IP banned. And so there's a few different kind of strategies back and forth between how people build scrapers and how web servers or like web developers will defend on their server side against scraping. So incorporating some kind of sleep timer is usually a good practice. And then we just import a few other typical libraries for a few different things. I use argparse to basically create an easy command line runnable executable. So the way that we would want to run this in the command line would be to basically call Python on our executable. As an input, I would be giving a part of the URL for the fundraiser that I'm interested in this case, Taking Back Our Freedom, Convoy 2022, and then a few binary flags that you can add. So one of them here is whether we want to write our output to a CSV. The other one is if we want to output the scraped HTML directly to file, and another on verbosity if we want to just print things out to terminal as we go along. I've made a few helper functions here that basically we can call to do those writing to files. But the essence of the scraper basically operates here. What you want to first do after having imported everything is set up a few variables. So the first is setting up our query URL. So this would be, so these are S strings in Python for those who aren't familiar. It basically allows us to, in these curly braces, input variables automatically. So here, basically, this base URL contains the string HTTPS, so on and so forth, to GoFundMe, where within the curly braces, it's going to input the string that we had put as our input fundraiser variable. So if we're going to call this in the way that we had defined up here, it's going to put in this string from the command line into that location. And then the query URL is basically that same thing, but also with donations. There's no real reason why this all couldn't have been done at once, other than I wanted to point that the base URL is to that original page, and that adding on this like / donations gets us basically that box that lists the donations up until a certain point. The other thing is we need to initialize a Chrome driver. So Chrome or like Google Chrome is what I use predominantly for my scraping usages. The Chrome driver is a way to automatically control the operations and navigation on the page. So the idea is we would run the script and it's going to load up the page and the DOM. So if there's any information that's rendered in JavaScript we can have it rendered at that time, and then we can use a number of different commands to navigate to different elements within that page, all through the Chrome driver. So we basically initialize it here, and I put a list. So the Chrome driver will appear on my device because I have it set up basically in the same folder for, because I'm on a Mac, so I'm using Mac, and for the Chrome version that I have now. But you would want to do the same for yourself. So I added a link to download your own version of the Chrome driver here. But basically, this is just saying my Chrome driver executable for those on Windows, it would be Chrome driver.exe. It's just located in the same directory as where I am right now. So what this asks to do is it basically will load up the page. So this will instantiate a Chrome instance that will navigate to that page. And then what we want to do is find certain elements. So here I point to the fact that we want to use developer tools. So I'll jump back to this web page. And the idea is I want to know where these names and these $signs and this time element, where those reside within the rendered HTML or HTML through JavaScript. So I'll press F12, and you can also right click and go to, I think it's inspect. This would pull up all of this this panel that has everything that you need to kind of navigate through and see the inner workings of the web page. And one thing that's particularly important here is to try and select a given element on the page. So when I do this, it starts to allow me to kind of hover over different component elements within the page. So at least within here, there's this like header information. There's this component div that seems to hold most of the information. There's these container divs that seem to have like listed items within them, and then within those there's divs that have an image here for the given donor, and then these other divs containing other information. And so the important here is this is pretty much the element I want to select. So if I click on this, it will actually point me or direct me to what that is in the rendered HTML. So if I close down some of this, we can see that when we get into this class list unstyled O donations list, we can see that there are all these elements, each of these. So as I kind of hover over them, you can see them highlighted in the HTML of the page itself. So that actually contains everything that we want to scrape, right? So here, say for this first one, as we drill down, we can see that in opening each of these up, we get closer and closer to the divs that we want, right? So within this div here, this class mPersonInfo name, we have that text information that we would want to grab. In this other one, the mPersonInfo content, that seems to contain both the donation amount and the time. So as we go into that, we have this other unordered list where we can see there's two meta list names. Those seem to both contain the things that we want. So we'll drill down into that. This first one has with a span with class name weight 900. It has the $10 that we want to grab. This other one has the timestamp and so on and so forth. And so this substructure or subfolder is basically going to be replicated for every other one of these. So there's certain elements, those certain tags we'll want to define as we're developing our scraper. So if I go back to the example, so the idea here is we want to find all those elements, and there's a certain, because all these pages can be rendered in HTML or XML, there's a way to grab those specific locations based on what's known as a different as a parse tree, and a direct link to some of those parse tree elements can be acquired through this Xpath. So if we go back here, what I want to do is initially grab the entire container that that has each of these elements. So I can click on that, and so you can see this is the container that has all of those listed elements. If I right click on this, I have the option to copy. And one thing I would want to do is copy the XPath. There's also the absolute path that you can get. But if you copy that XPath, what that will basically give you, I'll just go over to a terminal here, and if I print it out, is basically that thing that we had added within our scraper. So it's if I just go back here again to this page, it's basically this content. So I'm saying find basically that container that has all this listed information, and what it will return is basically a Selenium object, a Selenium tree that we can parse in certain ways. The only reason I add an index to 0 is that it might return multiple of the same elements, and there's only one in this case, so I only really want to grab the 0th. Otherwise, it's a list containing that one element or that one parse tree. I really just want the parse tree. So that gets stored to this variable elements to parse. I have this nice verbose flag just to print out, what that object is. It shows that it's a Selenium object with certain ID and information, but it's not very useful to us right now. Then the like pretty much last, well, not the last thing we want to do, but the most important thing we want to do then is within that parse tree that we have, there's other kind of parsing commands we can operate on. So we want to find elements by class name in each of these cases. So the M person info name, if we go back to here, was the one element of information that we really wanted. So it's a div, but it has a very unique class. So the M person info name gives us basically this object. And what we want to do is call on that object the dot text attribute, because that will give us then back exactly what we want, this name. And we want to do the same thing, but there's a kind of like a deeper parse tree to go through. So there's this other list where we have M meta list item, and that's copied over in 2 ways. But this one has also the class weight 900. So if I want to grab all of these sub elements, so the $, I would do the exact same, I would do the exact same thing where now I'm looking for everything by weight 900. And then finally, everything that's an M meta list item. There's a bit of redundancy here because this last time since, so that's the one that we want to, a list that we want to represent the time since the donation was made. We just want to exclude from that anything that has a $, because it will have grabbed both the amounts and the time since. So I have a quick list comprehension here where I want each of the elements for I in time since, as long as the element doesn't have a $, in it. So it's just everything that's not a dollar amount. And we want to do that from the value itself. So this is that element plus grabbing the value itself using this dot text command. And so I print these out. I'll probably remove these in a future version on here, but this just shows that we can then print out what all of those elements are by calling dot text on each of them. We'll print them out in order. So just to be clear, names is just grabbing, say for the 40 some entries that are available in that one snapshot of donors, it's just grabbing each of the name elements of each. So 40, a list of 40 elements that contain the donor's name. The amounts are just that in the same order, just the dollar amounts, and the time since after doing this small cleanup is just the times between. So we basically have 3 lists that we then want to combine. So I just do a quick list comprehension here where basically I'm going over the indices of those 3 lists. And all I'm saying is go get the ith index of name and get the text value for it. Go get the ith index of amounts, get the text value for it, and go to the time since, the ith value, get the text for it, put that into this 3 tuple. So it's a list of 3 tuples, but that basically contains everything that we want. So I have this other thing where it will print everything out for verbosity's sake. It will then send the information to this this small function that I had defined that writes the tuples to CSV. And then we can also save the source file. And that's pretty much it. We just want to make sure we close the driver. And so this will basically, when launched, load up the page, go to the donations, grab all that information, format it into this this list of 3 tuples, write that out to CSV, and basically be done. So to actually demonstrate how that all will work, what I'll do, so I just need to get rid of this. So using assuming that you have your Chrome driver set up and each of these pip dependencies set up, here's just an example way that you could run this. So maybe even before I do that, what I'll do is just show you, I'm running this from the scraping tutorial. So for example, this is what it should be. You should have your Chrome driver executable listed within here. So, oh, whoops. Let me just copy that over again. So when I run this, what this is going to do is auto run the page. So right now it's loading everything up. I'm not doing anything here. It's grabbing this latest version of the donations snapshot, and then it closes everything down. If we go back to this page, we can see, or to our terminal, we can see each of those elements. We had printed out what that Selenium driver web element was. This is the first list of all those names. This is the list of all those donation amounts. This is the list of all the times, and then we basically just want to combine that together. So what I get here when I just list all the files is by having added on that those commands for .c to save to CSV, .s to save to source, I'm basically saving these to file with the name of the charity in mind, or the fundraiser in mind, and then a timestamp down to the second level, so .csv. So if I want to just look at what's inside some of these, I'm just going to concatenate this and the CSV version. This is basically the readout of that list, and so we've effectively parsed and grabbed all this information. So Jack Giles, $40 2 minutes ago, Duran Davis, so on and so forth. This is all public information, so it's safe to scrape it. But the thing is, we can't access the GoFundMe entire history of donations. So the only way we can actually access this information is to have a regular scraper pulling information from this page. And that's kind of the beauty of what data scraping is. As data changes online in a somewhat automated way, because people are making donations on, in this case, minute levels, we can create a scraper to grab that information as it's being updated in a live manner. That's basically what CBC News had done, and the kind of motivation behind this work. So not sure how many people are willing or like behind or supporting this initiative. I'm not, but the idea here is there's a very significant question as to how much foreign interference might actually come into play during something like this, like in a destabilizing type tactic. And even CBC News in their preliminary analysis had come up with that same analysis through the some 35,000 donations that they had scraped since for about a week. There's a good number of these that either are being submitted under aliases, that are coming in under anonymous, or that even within the comments under certain ones, there's information about how people are submitting this from abroad, from outside of the country. So there's significant interest in trying to figure out in a very data scientific kind of investigatory way how much influence might foreign actors have in very national specific type movements. So it's a very timely subject. It's a very timely thing to put together. I would even say groups, if you're a group that might be interested in this kind of work, maybe getting this scraper together and running on a regular basis would be quite important and exciting. So reach out to me if that's something that's of interest to you. And hopefully this has given you a good sense for how to get started, at least in data scraping. And if you have any questions, feel free to reach out to me. All of this material, again, is available on the GitHub page. So all the best in getting your scraper started, and I'll see you all soon as part of the course projects. Bye-bye.